somewhat confusing the Internet of Things with the Internet of Everything. The Internet of Everything, of course, is a combination of all these market transitions that Blair has well articulated, and when they all come together to give us the ability to connect people, process, data, and things. It's the Internet of Things that is just the latest market transition that is allowing us then to connect the 99% of the unconnected. And that's being driven by Moore's Law and the continuing reduction in costs in computing and sensors. As a matter of fact, on the tip of my finger here, I have a sensor. Actually, this provides IP connectivity, this little chip.
How much does it cost?
99 cents. Gives us IP connectivity and has integrated Wi-Fi. And it's 99 cents. So,
fast forward 5 years?
Fast forward 5 years, pennies, right? And very low power. This still requires a significant amount of power. Forward, we're going to have sensors that are powered by the flex of your shoe, or the chemicals in the soil, or the heat from your body. And we're going to be able to take all of that data and bring it back and make new decisions.
So just like we're seeing with smart grids, you would actually move a lot of this intelligence right to the edge of the network.
That's right.
To be able to provide security, policy, etc., and to be able to make decisions at the edge, probably for the vast majority of interfaces.
And sometimes for machine-to-machine connections, for example. So John, join me over here. We're going to show a process, as you talked about connecting these silos. We're going to take the process of producing a cola, as you have your Coke here on stage with us.
Yes.
We're going to go from growing the corn for high fructose corn syrup all the way through the retail environment and how all of this needs to connect together to give us new value.
So as Jim walks through this, I'm asking each of the audience to think about your organization and think of it literally from the creation early on of the components of your supply chain through logistics into your manufacturing equivalent, sales, into distribution, into retail, customer interface, the closed-loop system that is all digitized together, that gets you the information you need to gain competitive advantage and the ability to run your operations with a lot more flexibility and ability to adjust up and down based on the economy at dramatically lower cost. Simple too.
Exactly.
Okay, got it.
Now, John, what we're going to do is we're going to start with the corn stalk. So we talked about machine-to-machine connections and local processing. Well, let's say that part of our field gets additional sunlight or favorable growing conditions. You want those sensors that are in the field to be able to tell the irrigation system, go ahead and water that corn. So that's an example of a machine-to-machine kind of connection. And we can see from our analytics dashboard here, we can see the irrigation system, that part of the growing area that's receiving those favorable conditions. We can zoom out.
So as Jim goes through this, think about this, that before we'd focus purely on productivity of a given amount of acreage and maybe doubling the productivity this can do. But you're talking about tying into the whole system.
That's right.
Okay? And Jim, those corn stalks over there, you've been doing a lot of work on. It can determine the water. You can probably increase the efficiency of your water utilization 40–50%.
That's right.
I've noticed them, you've got them in your home as well. I learned to fly a helicopter. I flew over your home the other day. There were big green plants out in your backyard with boxes around them. And I assume it was for purposes of this demonstration.
Yeah.
Does it have high margins?
It's good stuff, but anyway. All right, so moving right along here. So in our analytics page, what we're seeing is this area that we're having high production. Now I'm going to click here to show our facilities, and here's another example where the field can tell the facility that we need to gear up for additional manufacturing. In this case, to be able to process the corn, maybe more workers, maybe more machinery online so that we can deal with those loads. Now let's move from sourcing and let's take that right over to manufacturing. And we're going to show an example here where people are connecting with the manufacturing process, in this case through the social network of Twitter and Facebook. And we can actually see the map tweets about our CWI Cola product here. And most of them are blue, which is a positive sentiment. But there's a couple of areas here that are red coming from these limited geographies where people appear to be getting flat soda. So what we're going to do here is we're going to click and we're going to go ahead and scan this sample that came from the West Coast. And this will then show us the route that that soda took through the supply chain, through that digitized supply chain that you talked about, from purchase to distribution to the plant, where the bottling plant to where the corn was grown. Now we're going to take a look at this second sample that came from the East Coast, and we'll see that this sample also came through the same bottling facility. So this allows us then to start to triangulate and figure out, you know what, let's click on this Chattanooga bottling facility and see what's going on there.
So it's the ability to have all your data accessed in a way that ties it together. You're going to have an architecture.
That's right, exactly. Now we can see the path that both of these samples took through the facility. They both went through one common machine. If we click to drill down on that machine, we can see that there's actually a problem with the line speed regulator in our machine, and then we can automatically notify the technician, who, by the way, using a mobile device, gets that alert and then can find the map to find out where the machine is, maybe instructions to show how to be able to fix the machine.
So the average manufacturing plant in automotive, as an example, has 40 to 70,000 IP capable devices, the majority of which are really not connected. So what Rob Sudbury and team are doing is really the interconnected industries, if you will. So every segment of the supply chain, all the way through the retail, is going to be automated in ways we're just beginning to understand.
That's right. The people, process, data, and the things.
Okay.
Now, John, let's step over here into the retail environment. And I want to show you, first off, as I'm in the retail environment, I'm looking for my, whatever I'm going to be purchasing, in this case, maybe not soda, and I get an alert. You'll notice that on my mobile device, I'm getting an alert. It says, would you like to add 100 megabytes of free data to your cell phone or your mobile data plan? Well, this is an opportunity for the service provider potentially to sell bandwidth to the retailer to give them something to give to the consumer for watching an ad.
So this goes back to the issue of privacy. Most of us as consumers want our privacy, but if we're given the opportunity to open up to an application in exchange for bandwidth, that's something we're probably going to do.
That's right. Now, I click here to watch this ad, and then once the ad has played, I'm going to go ahead and we'll go ahead and finish that. And it tells me that the 100 megabytes of data has been added to my account. It wants to know, do I now want to know in the store, do I want to see a map to show me where these sodas are? So that then gives me a map on my mobile device to show where I can go to pick up this soda. Now, in addition to this, we're going to show you an application here from the back office viewpoint where we can take that data, these mobile devices that are in our environment, and what I'm going to do is take a look at this month's worth of data and look at dwell times. I click on run here, and this actually gives me a heat map to show me where people have stopped inside of the store.
So every retailer in the world wants to know the traffic pattern. They want to know where to put the goods with the highest margins that will get the most acceptance. And companies like Walmart, where I was on the board for a number of years, they required their board of director members, their management, to walk the stores regularly. Right. With this type of approach, you can do every Walmart store in the world every day if you want.
At every moment.
And you can see when they stopped and when they bought and when they didn't.
And when you start to combine that data with sensors that are on the shelves, potentially the point of sale information from the cash registers, and even new things like parking lot sensor. This is a street line sensor that tells you if there's a car in a parking space, for example. So you can begin to see that there are new applications. You can advertise to the consumer, not only do I have the product in stock, but I have a parking space for you as well.
So we used to think of these applications as kind of separate. When our CIO, Rebecca Jacoby, talked to her counterparts about literally being responsible for parking spaces in the Cisco buildings, people kind of said, what are you doing? It's the interdependency of all these applications that make a huge difference. You know when to turn on the air conditioner or the heat in the building based upon the number of spots. You know when to put extra cashiers at the cash out line based upon how the parking lot filled up. The average Parisian spends 2 years of their life looking for parking places. We'll solve that problem. But the real problem here is how do you interconnect this data that we're gathering?
That's right. And John, actually, I brought a slide that just shows how we bring all of the different components together. At the bottom, these new sensor networks are going to require, this is where we're seeing the rapid adoption of IPv6. We need all of these millions of sensors that are going to be connected to have their own location information, their own IP address.
So a subtle hint to our engineers, we need IPv6 everywhere.
That's right, that's right. The things that we're doing in new routing protocols to be able to take devices that may only wake up for a moment and burst a bit of data out to the network, and then be able to collect that at the field area network layer and capture that data and turn it into actionable information, bringing it back through the core and into the data center where we can then run analytics on it. Or processing it down at that local level. You talked about moving UCS out to the edge and moving the processing closer to where all these sensors are so that we can aggregate that information and bring it back. John, this is that architecture that you're talking about and the approach that we're going to need to be able to solve this problem and to tap into that $14 trillion of value.
Jim, absolutely awesome. Well done.